All right, guys, welcome to Monday. Go ahead and get out your homework. How's your weekend? What'd you do, Jackson? Anything fun? Huh. Okay. As always, I'm going to call out the answers. You're going to check your work. You're going to count up how many you got wrong, and then you're going to answer question one on the Google Forms. So here we go. We had 1 through 13 all. So questions 1 through 4, you were supposed to actually make the drawing of this. So obviously, I can't check that part. So we're going to start off with question number 5. Question number 5 just said check the formula. In other words, write Euler's formula. So on question number 5, you should have written 7 plus 7 minus 12 equals 2. On question number 6, you should have written 8 plus 12 minus 18 equals 2. If you have to rewind the video, please do that. Question 7, 7 plus 10 minus 15 equals 2. And question number 8, 8 plus 12 minus 18 equals 2. I think questions 6 and 8 were hard simply because it's hard to count all those edges and vertices and faces because the shapes are very strange, and you got to kind of figure out what's behind shapes and whatnot, and they're obviously a 3D shape drawn in 2 dimensions. Okay, so the ones that I tried to give you a good explanation on were 9 through 13. Remember, you were supposed to look at the previous page back to the regular polyhedrons in order the platonic solids there to get your the picture of what they were asking about. All right, so here we go. So each one of these has 4 answers, and I'm going to read them from left to right. So on question number 9, E is 6, V is 4, F plus V is 8, and E plus 2 is also 8. Hopefully that makes sense. Number 10, E is 12, V is 8, F plus V is 14, and E plus 2 is 14. Number 11, E is 12, V is 6, F plus V is 14, and E plus 2 is also 14. Notice the pattern? Hopefully you did. All right. The pattern is the last 2 columns, the numbers have to be the same. All right, number 12, E is 30, V is 20, F plus V is 32, and E plus 2 is also 32. And the last one, number 13, E is 30, V is 12, F plus V is 32, and E plus 2 is 32. How'd you do? Brett, you get all those right? I bet you did. All right. Go ahead and answer question number 1 on Google Forms, and then come back to the slideshow. All right. So today we're going to do 10.6, and on Wednesday we will have a quiz. The next slide we'll talk about what's going to be on the quiz. Obviously the quiz is going to be taken at your home. It's going to be taken on the computer. Certainly you need scratch work. You can still use a resource card. This will be a calculator quiz as well too. You can use the calculators. All right. Okay, so we're going to do a new section today, 10.6, and then we'll take a quiz on Wednesday and do a new section, and we're just going to keep rolling on. So it looks like we got a test next Friday, not this Friday, but next Friday. So what am I going to ask you on the quiz? Well, it's going to be a multiple choice test, and it's going to be on the following topics. You need to be able to calculate the area of rectangles. You need to be able to calculate the area of a parallelogram, area of a triangle, area of a trapezoid, and area of the circles. So those 5 things right there. In other words, it's going to be on sections 10.1 through 10.3. So yes, you better make sure you have a resource card. No, you can't go online during the quiz. I need you to be good, ethical, and virtuous students. And it'll be a normal quiz. I'll probably give you about 15 minutes, and then we'll do the class after that. Okay, it's going to be 2 different links as well too. When you get your daily class links, it'll have a link for the quiz and then a link for the class. Please do the quiz first and then do the class. All right, here's your homework tonight. Write it down, please. Okay. All right, so we're going to switch into 3-dimension world because we're going to be doing volume of prisms today. So we're out of the 2-dimensional world, and now we're going to get into the 3-dimensional world. 2 basic objectives today. We're going to do volume of rectangular prism and volume of a triangle prism. 2 different formulas, or are there? We'll see about that here in a second. So think about this. We started the chapter, and this is a pretty good review for the quiz as well, too. Everything I'm about to mention will be on the quiz. We started this chapter. We did area of a rectangle and parallelogram. Remember, for area of a rectangle, it's length times width. And for parallelogram, it's base times height. And some of you realize that you could also use base times height for rectangles. Now, notice I don't have squares there because squares are rectangles. We did area of a triangle. Remember, that's 1/2 base times height. We did area of a trapezoid, the really weird formula, right? We add the two bases together, multiply by the height, and then divide by 2. And lastly, we did area of a circle. Area is equal to pi r squared. All of those are in square units. Don't forget your units for the quiz on Wednesday. Okay. So for all those shapes, we were calculating area. And remember, area is how much space is in a two-dimensional shape. So today, we're going to switch to volume because volume is how much space is in a three-dimensional shape. Okay, so by definition, please write this down. By definition, volume is the amount of space in a three-dimensional figure. And since it's 3 dimensions, we can't say the units are square units. Now we say the units are cube units or cubic units. For example, if it was in centimeters, it would be centimeters to the 3rd power. That means cubic. If you want to write out with words, then we'd say cubic meters. So 10 cubic centimeters, or 10 cubic meters. I'm not saying these two are the same, but 10 cubic centimeters or 10 cubic meters. Make sense? Okay, so for those you need a visual explanation of why it's not in square units, well let's take a box, right, our rectangular prism, and this time instead of filling it full of squares for area, square units, we fill it full of cubes. So there's the bottom row filled full of cubes. So if we fill the entire shape full of cubes and then count the number of cubes, for this particular one, there would be 120 cubes that filled that box. Remember, each one of those little cubes is 1 by 1 by 1. Okay? All right, so that's the visual explanation of why we measure volume in cubic units. So remember, squares, we fill a shape full of squares. For 2 dimensions, and for 3 dimensions, we fill it full of cubes. All right, today's class, we're going to be 2 things. We're going to do volume of rectangular prisms, to include square prisms or cubes, and volume of triangular prisms. We get, suspiciously, I'm going to say, we get 2 different formulas for each of these. All right, good news, bad news. The good news is technically it's only one formula for both. The bad news is it's not a very useful formula. So the bad news is you're going to get 2 different formulas for these shapes, one for rectangular prisms and one for triangular prisms. So think about this. If we were to come up with a formula for a rectangular prism there, so rectangular prism, and if you think about this, as you guys know what Post-it notes are, right? If you think about this as a really large stack of Post-it notes, well, if we wanted to find out how much space that stack of Post-it notes took up, well, let's see. We could calculate the area of the bottom, right? And then simply see how many of those Post-it notes we had stacked, right? That would be the height, or how many of them we had. And that's kind of this idea. So for volume, that's literally what the formula says to do. For volume, it says take the base area and then just multiply it by the height. So don't write this down. But the formula for rectangular prisms is capital B base area times the height. And you're like, well, that doesn't sound too complicated. It's just not a very useful formula because we still have to calculate the base area. So we got to figure out what its shape is. The same thing with a triangular, right? If you could imagine, I don't know if there are triangular Post-it notes, but if you could imagine triangular Post-it notes stacked on each other, well, to find the area, you'd simply calculate the area of the triangle on the bottom and then see how many of those triangles you had stacked on top of each other. So once again, this is the good news. The good news is that both of these shapes have the same formula, capital B times H, or base area times height. If you need to rewind that to hear that, please do. So yes, unfortunately, I am going to ask you to write this down, and then I'm going to ask you to never use this. But I do want you to realize that this is for all prisms, whether it's rectangular, triangular, hexagonal, any of the prisms. The formula is base area times the height, or the distance between the 2 bases. Remember, generally, the base is the top and bottom, but remember the prism could be on its side, so maybe left and right. So the distance between the 2 bases, or the 2 parallel sides, is what we define as the height. Okay? So I just made the claim that this is not a very useful formula, and it's not. I mean, it's just an explanation of what to do, right? What we would really like to do is is to have a more useful formula. So we're going to start off with the rectangular prism first. So once again, the basic idea is we got to do the base area times the height. Well, what's the base of this particular one? It's a rectangle. So what's the formula for a rectangle? Well, the formula for a rectangle is length times width. So in other words, the real formula that you're going to use for rectangle, this is the one I want you to write down, the real formula, the one that is useful, is length times width times height. For any rectangle, to include cubes, for any rectangular prism, the formula is length times width times height. That's a pretty easy formula. So how is it done? Well, I'm going to give you a rectangular prism. All right, so let's do another one. Let's do this one together. So I know it's a rectangular prism because it says it's a rectangular prism. So I know the useful formula is not capital BH. The useful formula is length times width times height. So what's the length and the width? The length and the width, if I look at the top, if I use that as the base, is 8 and 4, or 4 and 8. And the height, the distance between the top and the bottom is 7. Can everyone see where I'm getting those numbers from? Then all we got to do is multiply those numbers together. 4 times 8 is 32, and 32 times 7 is 224. And remember, the units will be cubed because it's how many cubes fit in this. So there are 224 tiny little cubes that can fit inside this box. And those cubes would be 1 by 1 by 1 meter. Make sense? All right, let's do another one. Who can beat me here? Landon H, can you already beat me to this one? All right, beat me to it. All right, so we know the formula. Well, yeah, it is capital BH, but the useful formula is length times width times height since it's a rectangular prism. Landon already beat me to it. All right, let's see. 3 times 2 is the length and the width, and the height is 13. 3 times 2 is 6. 6 times 13 is 78 cubic centimeters. We good? All right. So next box, box number 2 on the Google Forms, it says what is the volume for each one of these two shapes. So calculate each one individually and then write down the 2 answers in question number 2 on the Google Forms. And then pause the video while you're doing that and then come back for the answers. All right, what'd you get? Callie, what'd you get for the first one? Do you agree, Jackie? Yep, you're both right. It is 96 cubic centimeters. All right, the second one, let's see. Length and width is 1 and 5, and the height is 6. 1 times 5 is 5. 5 times 6 is 30, so 30 cubic meters. How many of you guys got all those right? Okay, moving on. So rectangular prisms, pretty simple, right? The more challenging one is the triangular prism. You're like, why would this be more challenging? Why? Because it's a triangle as the base, not a rectangle. So even though, yes, technically the formula is capital BH, so the base area times the height, well, the problem is our base now, or that we need to calculate area of, is a triangle. And so therefore we have to use the formula for area of a triangle. Well, we know the formula for area of a triangle, right? The area of a triangle is 1/2 base times height. But then we got to multiply it by that second height there, because remember that big capital B is the base area. That's 1/2 base times height. And then we got this other h. Well, that looks very confusing. Therefore, they're going to put some names on the 2 h's, because the first h is the height of the triangle. That's what the TRI means there. And the second height is the height of the prism, the distance between the 2 triangles. So right there in yellow is the formula you're going to use. So the formula for a triangular prism is 1/2 times the base of the triangle times the height of the triangle times the height of the prism. That looks awfully complicated. Okay, so make sure you pay attention and see where I'm getting these numbers from. All right, if you need to rewind that and hear that one again, please do. Let me show you an example. So it says, find the volume of a triangular prism. So I should see 2 triangles. Do you see the 2 triangles? All right, so remember, we got to calculate the base area of that triangle. So I just made it blue. So that's the area of one of those bases. Well, I know the formula is 1/2 base times height. So how do we find the base and the height of the triangle? Just the blue part. Yeah, we look for the little tiny square. So David, what's the base and the height of that triangle? That's correct, 12 and 20. So notice that the 12 and the 20 both are attached to the little tiny square. Does everybody see the little tiny square? And now notice which triangle you pick is kind of important. If we pick the back triangle, well, it doesn't list the base of it, so we'd have to go to the other triangle. So sometimes for the triangular prisms, you're going to have to look at both triangles to find the base and the height, because sometimes it'll be one they'll label the height and the other one they'll label the base. So make sure you look at both triangles in order to find the correct measurements. All right, but we are not done with the formula. Remember, there's that other h there. Remember, that other h is the height of the prism, and we define the height of the prism as the distance between the two triangles. Well, the distance between the two triangles is, 25. Okay, so those are the three numbers I need to use. So the base of the triangle is 12, the height of the triangle is 20, and the height of the prism, the distance between the two triangles, is 25. Can everyone see where I'm getting those numbers from? Okay, so this is just a big calculator drill. 12 times 20 times 25 divided by 2. Leonie is... She's grabbing her calculator. She's punching the numbers. Do it one more time, Leonie. One more time. Just confirm your answer. Remember, you can always fat finger something. So you wanted, if you're using a calculator, do the calculation twice to confirm. Final answer is... That is correct. 3,000 cubic feet. Good job. Okay, let's do one together. So this time, notice now as you would like, the two bases are top and bottom. But just remember that the bases could be left and right if it's on its side. So there on the bottom left, there is a form we need to use: the base of the triangle times the height of the triangle times the height of the prism. So to find the base of the triangle and the height of the triangle, we find the little square. Look at the little square there on one of those triangles. Well, the bottom one doesn't have any numbers. So let's look at the top. The top one, I see the little square. The two numbers attached to the square are 3 and 4. So that's the base and the height. Notice that other number there on the triangle, 5. It's not a bad number. It's just a number we're not going to use. Okay? All right, and finally, the distance between the two triangles is 8. So those are the numbers I'm going to use. So 4 and 3, or 3 and 4, are the base and the height of the triangle, and the height of the prism is 8. So I simply do that math. Let's see, 4 times 3 is 12, 12 divided by 2 is 6, and 6 times 8 is 48. There's a bunch of different ways to do that one. I could do 4 times 3 times 8, which is 96, and then divide that by 2. I could do half of 8 is 4. 4 times 4 is 16 times 3 is... Okay, I'm going to stop telling you all the possible ways of doing that. If you're using a calculator, what I would do is 4 times 3 times 8 divided by 2. Does that make sense? Okay. Okay, let's do one where the prism is on its side. Notice triangular prism on its side. Okay, so let's see, we need 1/2 base of the triangle times the height of the triangle. So I find the triangle with a little square. There it is. The base is 8 and the height is 3. So 1/2, 8 times 3. And then the distance between the two triangles will be the height of the prism. So the distance between the two triangles is 12. So let's see. 8 times 3 is 24. Half of 24 is 12. And 12 times 12 is 144 cubic centimeters. Okay, I did that one kind of quick. Notice most of you probably would do 8 times 3 times 12 divided by 2. I just chose, because I'm doing it in my head here without a calculator, to do the math a little bit easier. Okay. All right. If you need to rewind, watch all those examples again, please do. If not, and you're ready to see if you can do this one by yourself, go ahead and do these two by yourself. This is question number, what are we on, 3 or 4? I think this is question number 3 on the Google Forms. Okay, it's box 10. All right, how'd we do? What'd you get, David, for the first one? That is correct, 240 cubic inches. And Chris, what'd you get on the purple one there? You sure? You sure? Can I convince you didn't get it right? No, you got it right, 48 cubic feet. All right. All right, so there is one last thing I want to show you, and this is called extra information. It's not wrong information, it's just extra information. Notice on the left one there, I list almost all the side measurements. On the right one there, I list a whole lot of information there. Some you will use and some you will not. So on your own, I want you to try those two and then answer the last question on the Google Forms. I'm not purposely trying to fool you here because I am giving you correct information. I'm just giving you more information than you need. All right, how'd we do? So if I consider the top and the bottom of the left one there, as my base, then that means the length and the width are 5 and 6, and the height is 7. So 5 times 6 times 7, 5 times 6 is 30, and 30 times 7 is 210, so 210 cubic centimeters. So you generally, I can't really confuse too many people on the rectangular prisms, but the triangular ones I certainly can. So if we look at the second one there, the one on the right, if I look at the triangle, well, the top triangle has sides of 7 and 8, but notice there's no square there, no square on that top one. The square is on the bottom one. Remember, the square is the base and the height. So the base and the height of the triangle is 9 and 6. Can you see that? And the distance between the two triangles, is 10. So 9 times 6 is 54, half of 54 is 27, and 27 times 10 is 270 cubic kilometers. Okay, so that wasn't a whole lot of stuff. Just remember, if you ever look in the book, it's always going to say the formulas for any prisms for volume is capital BH. It's not a very useful formula, so the two formulas that I gave you are the ones you're going to need to use tonight to get to your answers on homework. Yes, you may use a calculator. Okay. So those were the two objectives that we just did. Here is your homework for tonight. Remember, you can always email me if you have any questions. You got 2 days to get this done. So with that, I will conclude the class, and I will see you. Oh, don't forget, quiz on Wednesday. Quiz on Wednesday. There'll be two links. Do the quiz first, and then do the class. So with that, I'll close class, and I will see you guys on Wednesday.